We're now ready to look at problem 14. Find the angle between the two vectors u and v, where u equals this and v is this. So for this problem, we have, it's like a little formula. Excuse me. So let's go ahead and I'll write down the vectors, then I'll write down the formula and we'll apply it. So vector u is negative 10I plus 2j. And vector v is I minus 8j. So anytime you have two vectors, so for instance, u and v, we've got this formula, cosine of theta. Now this angle will be the angle between these two vectors. In the numerator, you have the dot product. So this right here is the dot product of these two vectors. And we'll talk about what the dot product is in a minute, over the magnitude of the one vector times the magnitude of the second vector. Now the dot product of two vectors is where you multiply the I parts of the vectors. So negative 10 times 1. Let me make it clear. So you multiply the I parts and then you add that to the product of the j parts. So minus 10, minus 16, negative 26. It's interesting. Earlier in this review, we added and subtracted vectors. And when you add and subtract vectors, the answer is another vector. However, when you take the dot product of two vectors, the answer is just a number. So this is actually a number. It's not a vector. So if we go, so the dot product is negative 26, that's the numerator. So the magnitude of u, we've done that before, right? So you just take the square root of negative 10 squared plus 2 squared, square root of the whole thing, times magnitude of vector v, which is going to be 1 squared plus negative 8 squared. So now I grab your calculator. Actually, I can simplify this a little bit. Negative 10 squared, 100 plus 2 squared. This is like square root of 104. This is 1 plus 64. So if I multiply all this stuff, negative 0.3162. So therefore the angle is the inverse cosine of negative 0.3162. $108. No, actually, what I could have done at the beginning was sort of sketch these vectors, and we'll see if this answer looks reasonable. So negative 10 plus 2j 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. There's like vector U. Then vector V is negative I minus 8j. So I, then 1, 2, 3, 4, 5, 6, 7, 8. So obviously 90 degrees would make this the right angle. So it's bigger than 90. So 108.4 looks pretty reasonable. Now, let's look at the next problem. Actually, there are 1, 2, 3. The next 4 problems are all similar. So let's just look at the first one, then we could do them all. So now we're going to still be using this formula we were just working on. We were just using. Here's another kind of problem that we can use that formula for. Question is, are the following 2 vectors, so here are 2 vectors, are they orthogonal, are they parallel, or neither? And if they are parallel, then indicate whether the direction is the same or opposite. So we're having 2 vectors. Basically, what we're going to do is we're going to find the angle between the 2 vectors. Excuse me, an orthogonal angle means, if the vectors are orthogonal, that means the angle between them is 90 degrees. If the vectors are parallel, then the angle between them is going to be either 0 or 180 degrees. And then neither means it's just a random angle. 20 degrees, 47 degrees, 99 degrees, whatever. So basically, it's just a matter of applying this same equation. So for number 15, the 2 vectors are 2, 6, and -1, -3. So the dot product, I'm going to multiply the x parts and then add the product of the y parts over the magnitude of each vector. This is 2 squared plus 6 squared. This is -1 squared plus -3 squared. So it's like I have -20 over 4 plus 36 square root of 40 and 1 plus 9. -20, sorry, -20 over so actually -20 over 20, which is -1. Now let's use a little common sense. So what if we say way back when we first started trig, if we said, what's the angle where the cosine is -1? Go back and think of your unit circle. Where around the unit circle is the cosine -1? Well, right here. What's this angle? You could say pi, or you could say 180 degrees. So we say that these are actually parallel vectors because they run along the same line, but they're opposite direction. So the answer would be parallel and opposite direction. And just for fun, if we plot these two vectors real quick, we should see that. So 2, 6. 1, 2, 3, 4, 5, 6. So here's the first vector. And then -1, -3. Of course, my sketches aren't perfect, but you can see, yep, that's what's happening. So I got 3 more of these. Problem 16. The two vectors are 2, 3, and 6, -4. Same thing, dot product, 2 times 6 is 12, plus 3 times -4, -12. You know what I'm going to do? I'm not even going to continue this because look what my numerator is, 12 plus -12. So I'm going to have 0 over something. I don't even care what the something is. This whole thing is going to be 0. Once again, if we think back to our trig days and we think what's the angle where the cosine is 0, pi over 2 or 90 degrees, which means these two vectors form a right triangle, which means they're orthogonal. So these two are orthogonal. As a matter of fact, once again, if I make a sketch, we'll see if it sort of looks that way. 2, 3, and then 6, -4. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yep. Looks like it could be a right triangle, orthogonal. All right, 2 more. So the first problem we did, the angle was 180, so they're parallel opposite direction. This one, cosine of theta is 0, which means the angle is 90 and they're orthogonal. See what 17 is. -2, -5, and -4, 8. So the dot product, -2 times -4 is 8, and -5 times 8 is -40. Magnitude of this first vector is going to be -2 squared plus -5 squared. Magnitude of the second vector is -4 squared plus 8 squared. Looks like -32 over 4 plus 25, 29, 16 plus 64 is what, 80? Grab my calculator and do this math. It's like -0.6644. So then I take the inverse cosine to get the angle 131.6 degrees. So this, in terms of the answer, it would be a neither, which means just an angle. 1, 2, 1, 2, 3, 4, 5. And then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. $130, that looks reasonable. And now the last one of these kinds of problems. -3 halves 2 and -6/8. So dot product, I got a fraction here. So -3 halves times 6 is actually 9. 2 times 8 is 16. -3 halves squared, this is going to be messy, plus 2 squared times -6 squared plus 8 squared. So this is 9/4 plus 4. $16. I think this is 25/4. 25/4 times 36 plus 64, I think is 100. So even though it looks ugly, turns out this whole thing equals 1, amazingly enough. So the cosine of theta equals 1. Once again, think of the unit circle. What's the angle where the cosine is 1? It's right here. 0 degrees, which means these vectors are parallel in the same direction. -3 halves 2. That's like -1.5 and then 2. Which is not very good. And then -6/8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So maybe up in here somewhere. Once again. Yep. All right, now 3 more problems, and they deal with the last topic on this test, and that's polar coordinates. So 19, given 5⁻⁶ in polar coordinates are theta, give 4 other polar coordinate representations for this point. And at least one representation use r less than 0 and another representative use theta less than 0. All right. The polar coordinates. Once again, this is not necessarily a teaching video, so You can watch the video on polar coordinates. So this is a problem where they give us a polar coordinate of 5 pi over 6. So I'm going to plot this point as a polar coordinate. So you always do the angle first. So pi over 6 is sort of in here. It's like a 30-degree angle. And the length of 5. So from here to here is 5. So maybe up here, it's about right here. So that point there in polar coordinates is 5 pi over 6. Now we need to find 4 other designations in polar coordinates that are actually the same point, but the polar coordinates different. So there's lots of ways you can go about it. For instance, let's do the thing where if this is pi over 6, how about I do an angle where I go all the way around, which is 2 pi, and then I stop here. In other words, 5. So 2 pi over 6 plus pi over 6 is 13 pi over 6. 5, 13 pi over 6 is right here. So there's another polar coordinate that actually ends up being the same point. Now they said they wanted at least one problem to have a negative r. So a negative r means what I really need to do is I need to go have my angle be over here. And then by making the r -5, it flips it over here. So that angle, so first of all, the r is going to be -5. That angle, I believe, should be 7 pi over 6, right? So if I go plot this point, 7 pi over 6, the angle's right here. 5 is here, but because it's a -5, it causes it to flip the other side. So this point right here is -5, 7 pi over 6. They also said to use a negative angle. A couple things I could do. I could go here again and have a negative r, and this angle right here. So that's a negative angle direction, and that should be -5 pi over 6. So -5 pi over 6, and 5 is right here, but -5 bumps it to here. And then just for fun, I could go a +5 and then go all the way over here, which I think that angle would be 11 pi over 6. So there's all kinds of possibilities, all kinds of different polar coordinates that actually end up being the same point. So these 5 are actually all the same. So now the last 2 problems, polar coordinates, are going back and forth between rectangular coordinates and polar coordinates. Rectangular coordinates are like x and y, how you define a point with x and y, and polar coordinates are r theta. So here's our polar coordinate, 6, 5 pi over 4, and we want to convert that to x and y. So in polar coordinates, it's 6, 5 pi over 4. And what would that be in rectangular coordinates for x and y? Well, the nice thing is formulas we use here are just like the formulas we use for vectors. X is r cosine of theta. So it's 6 times the cosine of 5 pi over 4. And y is r times sine theta, which is 6 times the sine 5 pi over 4. If you want to give an exact answer, cosine of 5 pi over 4, if you think about do a circle, it's going to be -2 square root of 2. No, it's negative square root of 2 over 2, sorry. And sine of pi over 4 is also. So both of these, x is about right like this. So the point is going to be -3 square root of 2, -3 square root of 2. If you're going to write it as a decimal, you'd say -4.2 and -4.2. And the last problem, they give us a point in rectangular coordinates. And they want to know what that would be in polar coordinates. Once again, we use the same equations that we used back when we were working with vectors, going back and forth between the ij and magnitude direction. So the r is just the square root of the x squared plus the y squared. 4 plus 9 square root of 13, or 3.6. And once again, just like with vectors, the theta is going to be tricky. Matter of fact, I know this is in the 4th quadrant. So this initial calculation is not going to be really the correct angle. Once again, here's my angle. We'll see what this calculation gives me. Inverse tangent of y over x. Inverse tangent of -3 over -2. So inverse tangent of 1.5, 1.5. 56.3 degrees. Whereas 56.3 degrees actually going to be that angle right there. So that means this angle here is also 56.3 degrees. So my actual angle is going to be 180 plus 56.3 degrees. If I do this correct in my head, I think the angle should be 236.3 degrees. Or on the answer key, I gave the answer in radians, which is sort of strange, but let me see, 236, so let's say, well, I guess if I convert this to radians, 236.3 times pi divided by 180. 4.1 radians. Okay, so those are the review problems. Hopefully that helps you if you get stuck or don't quite understand what you're doing.